constant speed. So constant speed, it means submission force equals 0. Newton's second law, F equal ma. So the submission of the forces here, which is m times aa, is acceleration. So the acceleration is 0 as well. So it means the constant speed. The examiner highlighted, we need to highlight, sorry, weight and resistive forces acting on the box. Okay, so let me draw the diagram here. We have a slope and there is a kind of a box. So the weight is acting on the center of mass and on the inclined or slope, and the kind of reaction or normal contact force from the surface. Okay, let me uh, resolve or solve the weight into two components. So we have two components here with different color. So here we have a vertical component and this is the horizontal component. So this one here, we have a small angle theta and equal to this angle as well. So this component, we call it W with the side, so we call it cosine theta, and this component, which is W sine theta. Okay, if you're sliding and there is no external force, so I have to draw another type of force here, which is let me change the color here, which is the friction force here, which is Fr. It's kind of resistive force. Okay, so I change the sentence or the question into a diagram so make it easy for me. So now the resistive force Fr equals the horizontal component, which is W sine theta. The examiner said constant speed, so these two forces must be equal, no acceleration. Remember that Fr here as a resistive force equal weight, which is mg, mass times the gravity times sine the angle. The mass, by the way, it's constant. Gravitational field strength or acceleration due to gravity, it's constant as well. If you want to change the resistive force, the only factor you can change it, which is the angle between the slope and the horizontal here, the surface, for example. Okay, let me have a look at the choices for go from D, for example, to A. The component of weight perpendicular of the slope is greater than. I cannot use greater at all because he said constant speed. Component of weight perpendicular to the slope is equal to the sum of resistive force. Cannot. I'm targeting the component which is horizontal one. The component of weight parallel to the slope greater than, if it's equal to, I can choose this one. So the last one here, which is A, the component of weight, which is parallel, yes, which is horizontal and parallel to the slope, is equal to the sum of resistive forces. So the choice A is the correct one.